name's Cassie Walther. I'm going to teach you like a brief look into topology and a really quick introduction to what the Mobius strip is. Hopefully I'll spark your attention and interest and leave you with a question to figure out for yourself if you love this stuff as much as I do. We're going to need a pair of scissors, tape, paper. So let's start off with the simplest shape, which is literally a piece of paper. I'm going to cut it in half just because it's a little bit easier to deal with. I'm just going to fold it and tape it and see what happens when I want to start cutting it. Well, it turns out if you cut it right in half, you end up with 2 half pieces. And again, if you cut it into quarters, you end up with quarter pieces. Sort of obvious, not a whole lot's happening. Most people that know nothing about topology will figure that out. The interesting question is what happens when you take this piece of paper and you just do a simple half loop. And tape it there. My perfect one that is pre-made, just like the chefs do. So what's going to happen if we take this and also cut it right in the middle? It ends up that you double the length of your Mobius strip and you add 3 more loops. So here we had 1 half loop, here we have 4 half loops. I guess you add 3 half loops. Why is this happening? Like, why, when you cut this in half, are you getting a piece of paper bigger? And when you cut this in half, are you getting 2 different hoops? This is my term for hoops, apparently. So the easiest way to explain it is to notice that if you have this piece of paper and you walk along it, eventually you will fall off. Again, on this side, you will fall off. So there's 2 distinct sides to this piece of paper. However, if you do fold it with 1 half fold, I try to do it like this, and tape it, you can actually walk around it on both edges. This is what's referred to as the Mobius strip. Because you've taken a double-sided piece of paper and with 1 half twist turned it into a one-sided piece of paper, or a one-sided object. So it's a pretty nifty, amazing thing. Now the question is, what happens if you take your same Mobius strip and rather than cutting it in half, you decide to cut it. I think I just ruined this one. Did. Well, okay. We'll pretend. So what happens if you cut the same Mobius strip just a third away from one of the edges rather than halfway? It turns out magic happens. You get a link where one of them is the 1/n, whatever n that you chose to cut it away. We chose 1/3. And this is 2/3. When I say 1/3 and 2/3, I'm referring to the width. This should blow your mind. Like, this is maybe the coolest thing ever, and you've just done it with 3 or very basic utensils. Hopefully I've sparked your interest, and you are going to go onto Google right now and figure out exactly why this happens. This was a brief lesson by Cassie Walther, and I hope I get to meet you. Thank you.